In this video, we're going to look at some more angle pairs, and this one's going to deal with something called parallel lines and transversals. So, an example of a problem we're going to solve is something like this. Previously, we dealt with maybe just angles in this area, so a single pair of intersecting lines. The big difference here is I see two lines. This little marking here, these little arrows, mean that these two lines are parallel, and they are crossed by this line here. And I can see that I have a 112-degree angle here and an unknown angle there. And you may have some guesses as to what their relationship is. You can clearly see that this angle down here is obtuse. This angle up here is acute. So they're not the same, but this is what we're going to be learning about. So, what are parallel lines and transversals? And so, first off, we know that two parallel lines are, I'll say, lines with the same slope. We could say that they are coplanar and never intersect. There are a few different ways we can talk about that. A transversal, right here, is a line that crosses both other lines. And in here, and we'll talk about these specific angle pairs, but there are actually 8 angles we have here. 1, 2, 3, 4, 5, 6, 7, and 8. And so most of the pairs, more than half the pairs, actually have various names. And that's what we're going to look into. So, first up, a review of simple angle pairs. These are angle pairs from the previous videos. So vertical angles are two angles at the same vertex but across from each other. So for instance, this here and this here are vertical angles, and in vertical angles the measures are equal, so I could say x will equal y. Now I could have this and this, I could have that and that, I could have that and that. So there are many different pairs of vertical angles in here. We also still see a linear pair, and again, these are two angles that form a straight angle, or I'll say form a line. And like before, there are many cases like this. I'll put an A here, a B here. You can see that these two angles, angle A and angle B, actually come together to form a straight line. And in here, as before, if they form a straight line, that means they add up to 180 degrees. So I could say A plus B is equal to 180 degrees. So these are review from previous. This is nothing new so far. Now for the new pairs. So we have 5 new pairs to deal with. This corresponding angle is sort of the odd person out. So corresponding angles, we have this case where they are two angles on the same side of, I'll say, everything. It's not the greatest That's terrible. Same side of everything. It's not the greatest description, but what I mean is if we have our transversal, it might be two angles to the right of the transversal. And we'll say, let's say below both the parallel lines. So I could have x, I could have y. And so I can see that both of these are on the right side of the transversal. Both of these are below the parallel lines, so they are corresponding. Another way to notice corresponding angles is it looks like an F shape. Now, it could be flipped around, but you see I have this angle here, I have this angle here, and you can see this big old F going through there with these two angles. Now, the rule for corresponding angles is that they'll equal each other. They will be congruent. So I'll just say x equals y. Now, the next four actually use sort of four terms. So let me deal with these terms. So alternate or same side. So alternate is sort of opposite. Same side, of course, is sort of same. And that's talking about on the transversal. So are we always, in this case, to the left or to the right of the transversal? So same side would both be on the same side. For instance, x and y are on the same side of the transversal. Whereas alternate means one on one side of the transversal, one on the other. We also have the terms interior and exterior. So interior for us will mean between. Exterior will mean outside the parallel lines. So interior is this space here. This is interior to the parallel lines. Exterior means I'll have one angle out here and the other angle out there. So outside of the two parallel lines. Okay, so let's label some of these. So let's see, I've used x and y, let's use a and b. So alternate interior. So that means different sides, so one on the left, one on the right of my transversal, but both between the parallel lines. So alternate interior, I'll put, let's say, A there, I'll put B there. You can see they're opposite sides of the transversal, but between the two parallel lines. And the rule here is that these angles, alternate interior angles, will be congruent. So A will equal B. Alternate exterior, again, opposite sides of the transversal, but now outside the two parallel lines. So let's use C and D. And again, there are two different pairs of both of these. I could have A here, B here. I could have A there, B there. I'll put C here. And if I want to find the other one, well, this is one outside, so I'm going to go out here. I need to be alternate, so one was on, C was on the right side, I'll put D on the left side. And the rule for alternate exterior, again, is that they are equal, so C is equal to D. Okay, now, same side. And I'll sort of, it's going to be a little bit of a mess, but for same side interior, well, interior means between the two parallel lines. Same side means on the same side, and I can see that I have this x and this b that are on the same side of the transversal. They're both to the right. And between the two parallel lines, and I can see they're not the same. X is acute, b is obtuse, but the rule for same side interior is that they will be supplementary, or they will add up to 180 degrees. The final one, same side exterior, well, let's see, I have C out here, I have Y out here, so same side of the transversal. It could either both be on the right, both be on the left. In this case, both are on the right. and they're both outside of the parallel lines. I can see that the angles are not the same. C is obtuse, Y is acute, but because the lines are parallel, they will add up to 180 degrees. So I will have C plus Y is equal to 180 degrees. Okay, there's a lot of stuff in there. The most important thing for our quizzes and assessments, and the most important thing for something like the SAT, is not the names, it's remembering the equations. And it's actually much easier to remember the equations than you might think. You only need to remember two. So there were 8 angles here. But here's the idea. A lot of them are going to be the same. So this angle here will be the same as that angle there. They are vertical angles. This angle here will be the same as this angle here. They are alternate interior angles. This angle here will be the same as this angle here. They are vertical angles. And this angle here is corresponding to that. This is corresponding to that. This is alternate exterior to that. It doesn't matter. You see, like, there's many ways to get there. All of these angles I've marked as X will be the same. The other ones will be very similar. So I have Y here, vertical angles. From here to here, I get alternate interior. From here to here, I get vertical angles. And so all of these angles will be the same. And so either I will get the equation where I just make sort of x equal x, and very simple to solve. I could have more in there, but pretty easy. I get y equals y. So either one of them is where I just make them the same, or if I have the case where I have one of the x angles, one of the y angles, I'll just have to do x plus y is equal to 180 degrees. And anytime I look at a parallel line and transversal problem, I can just sort of figure it out and say, okay, do they look the same? So I notice both these x's look acute, so let's make them equal. Both these y's look obtuse, let's make them equal. It will work that way for parallel lines and transversals. This x and this y, they don't look the same. This x is acute, it's less than 90 degrees. This y is obtuse, it's more than 90 degrees, so they can't be the same. So they have to add up to 180 in this type of problem. Okay, let's look at a couple examples. So back to the first one. When I look at these two angles, I see that I have an acute angle x, an obtuse angle 112 degrees. Either I just use that rule we just saw and say, okay, they're not the same, so they have to add to 180 degrees. So x plus 112 equals 180. And then I can subtract 112 from both sides. And when I do that, I will get x is equal to 68 degrees. Or I could realize that these are same side, because they're both to the left of my transversal. Exterior, because they are both outside of the parallel lines. And the same side exterior rule said the same thing. Okay, in here, very similar, I can notice that I have this acute angle, 78 degrees. I have this obtuse angle, x. They are not the same, which for this diagram means they have to add up to 180 degrees. So I'll do x plus 78 equals 180. Subtract 78 from both sides. And I will get that x equals 102 degrees. Alternately, I could look at this and notice, oh, these are two angles that are actually combining to form a straight angle. That means that this is a linear pair. And same rule comes from linear pair. One more example. So in here, I notice that I have x and 129 degrees. They are both obtuse. So in this type of diagram, if they're both obtuse, I know that they both have to be congruent. So I'll just say, okay, x is equal to 129 degrees, and I'm done. If you want to look at it differently, I see this sort of Z shape, and that's sort of indicative of alternate interior angles. Alternate because one's to the left of my transversal, one's to the right. Interior because they're both between the two parallel lines. And the rule for alternate interior angles also told me to just make them equal to each other. One last thing I want to talk about before I sort of wrap this up. Sometimes you might have a problem that is difficult to address. So if I had parallel lines like this, they have to be marked parallel, and I had a transversal like this, it may be unclear whether this angle here should or should not be the same as this angle here, because all the angles look to be close to right angles. If that is ever an issue where you're not clear whether x equals y or whether x plus y is equal to 180 degrees, you can sort of skew the diagram. Take the same diagram, and instead of having this sort of perpendicular transversal, make it very harsh. And look at them again and say, okay, does this and x and this y look the same? They are both acute. Then it has to be this. If they look different, it would have to be that. But in this case, they look the same, so it is not 180 degrees. All right, there's going to be a link in the description to some worked examples, so we can get more familiar with doing this. There will also be a link to a worksheet so you can get some practice.